The abstract data type which is to be discussed is double-ended queue. Double-ended queue or DQ, also known as Deque, is a generalized version of queue data structure that allows the NQ and DQ operation from both ends. In ordinary queue, the insertion was from one end and deletion was from other end. Now, the DQ is the combination of stack and queue, as we can insert and delete the elements from both ends. In stack, the operations of push and pop are performed from one end, and in ordinary queue, the insertion is from one end and the deletion is from other end. But the double-ended queue is the combination of stack and queue in which we can apply the insertion and deletion from both ends. Now we discuss the application of the queue, double-ended queue, as it is the combination of stack and queue, because we have all the operations of stack and queue there in the DQ, double-ended queue. So it is it have all the operations of stack and queue, which are in stack we perform the push and pop operation, and in ordinary queue we perform the FIFO operation, which is NQ and DQ. NQ from rear and DQ was from front. So it is preferred abstract data type where we need both stack and queue at the same time. Like in minimum spanning tree, or we are the applications in which we find maximum and minimum value from sorted array in constant time, we prefer double-ended queue, as it supports the clockwise and anti-clockwise operations. So it is used in applications where we have to perform both type of operations, like in MS Word we apply undo redo, and in browsers we apply web browsers we apply backward and forward operations. And another application of double-ended queue is to check that the word is a palindrome or not. As to check the palindrome, we remove the first and last element and compare whether the elements are same or not. So the common operations of double-ended queue are, these are four operations: insertion of an element at the rear end of the queue, which is same as ordinary queue, and deletion of an element from the front end of the queue, which is again similar to DQ operation of ordinary queue, and insertion of an element at the front end of the queue, which is different from ordinary queue, as in ordinary queue we enqueue the element at the rear index. And other operation, fourth one operation we perform there is deletion of an element from the rear end of the queue, and the deletion from rear end of the queue is same as the in the stack or queue. So to implement the double-ended queue, here we define four different methods. If you recall the array list assignment, in which we discussed about 13 to 14 operations in the array list, if you remember, we performed the insert at end, insert at start, delete from end, and delete from start. In array list, both we have performed these operations in array list and in linked list. So we can convert the insert at end operation, insert at end method, and we can rename it as NQ value at the rear end. And We can also convert or rename, just we have to just rename the method insert at end to enqueue the value from the front end. So insert at start method can be converted or renamed as enqueue the value from front end. Just you have to rename that method. Rest all is the same. Delete from end operation, whether in array list or linked list. Here we rename just it as deque the value from front end. In deque the value delete from end, here in deque from end will be converted as deque the value from rear end, and deque from start will be converted as deque the value from front end. So the type, there are two different types of double-ended queue. These types are whether the input restricted or output restricted double-ended queues. The two types of input restricted double-ended queues are: element can be enqueued from only one end, and elements can be dequeued from both ends. There are two types of DQ or double-ended queue. These two types are whether input restricted or output restricted double-ended queues. In input restricted double-ended queue, here we have a restriction on input operations and output operations remain same. We have the either we have restriction on NQ from front or NQ from rear, but DQ operations can be performed from both ends, whether from front or from rear. Same as output restricted double-ended queues. In output restricted double-ended queues, we have restriction on DQ method. Here we can enqueue the elements from both ends, and we have to deque only from one end, whether it can be front end or it can be a rear end. Again, after converting these methods, which were insert at end to enqueue from rear, then insert at start to enqueue from front end, delete from end to be converted as deque from front, and delete from start to be converted as deque from start. We can we can well know that there are some issues again there in memory management. First of all, again, if we have only one element which is at last index or size minus 1 index of the queue, so again one of the solution is to shift the elements to right or left to perform the enqueue operation in the double-ended queue. But as we know, this is a costly solution. Again, the solution is circular queue. We have to implement the double-ended queue with circular queue. Consider the example of implementation of double-ended queue by circular queue. In this example, here the rear was at index 5 and the value at index 5 is 2. If we enqueue the new value in double-ended queue and the value to be enqueued is at rear index, so we will apply the formula as rear is equal to rear plus 1 mod queue size. So rear was at index 5, 5 plus 1 mod 8 is equal to 6. So the new value, which is 4, is to be enqueued at index 6, and we will move the rear at next index, which is 6. So after moving, the rear will change and rear will be point to at 6 index of the double-ended queue. Again, consider another example in which the rear is at index size minus 1 and the size of the queue is 8. If the size of the queue is 8, and as we know, the rear index, last index will be, maximum last index can be size minus 1. So that means rear is now at index 7, and if we enqueue the new value in double-ended queue, we will again use the formula as rear plus 1, rear is equal to rear plus 1 mod queue size. So rear is at index 7, so 7 plus 1 mod 8 is equal to 0. So we will change the rear from 7th index to 0 index, index 0, and we will place the new value 5 at index 0. So another example is of deque operation. If we deque the value from front, as in double-ended queue, we can insert the value at front and at rear in both ends, whether it is a front end or rear end. And to deque, we can, if it is not input or output restricted queue, then we can deque the value from both ends, whether it is front end or rear end. So to deque the element from front, again we will use the formula as front is equal to front plus 1 mod queue size, as the front is now at index 0, and after deque we have to change the front index by using the formula front is equal to front plus 1 mod queue size. Front is now at index 0, 0 plus 1 mod 8 is equal to 1. So our after deque, the value 0 will be dequed and front will move to index 1. So another example is of deque, and again the deque is from front end. If we apply the deque from front end, and consider this one example where the front is at index 7. If the front is at index 7 and we want to deque the element from front, so simply by using this formula, front is at index 7, 7 plus 1 mod 8 is 0. So the value 8 will be dequed, which was at index 7, and we will move the front at index 0. So after this, the front will move to at index 0. So consider this one where the element we want to deque is from rear end. This is slightly different, as we have to modify the formula as per our requirement. So to deque the value from rear end, we will use the formula as rear is equal to rear minus 1 mod queue size. Now the value at rear is 9 and rear is pointing at index 4. So after applying the formula, rear is equal to rear plus 1 mod q size. Now the rear is at index 4, 4 minus 1, which is 3, 3 mod 8, again we get the value 3. So we will deque the value 9 from index 4, and after that we will change the rear and move it to index 3. So hopefully you will clearly understand the concept of double-ended queue and priority queue, and after that we will discuss in detail the priority queue and double-ended queue in live session. Till then, Allah Hafiz. Thank you.